Let's work through the geometry midterm review. Topic 1, Geometry Basics. It says use the diagram to the right to answer the questions below. Name a point collinear to points S and T. Well, let's start with the definition. Collinear means they are on the same line. So a point that is collinear to S and T would be R. It is on the same line. Give another name for line B. All right, so line B is this guy here. You can name a line with two points. So we can call this line, and I'll write it like this. How about SV? Name a point non-coplanar. All right, the vocabulary here is coplanar. Coplanar means they're on the same plane. We want a point that is not on the same plane as points R, T, and U. So R, T, and U are on this flat plane here. So we would need either point V, which is above, or W, which is below. So we can say V or W. Number 2, use a diagram to the right to answer the questions. Name the intersection of planes JKL. So I'm looking at JKL. That's going to be this plane. That is the pentagon at the back of this diagram here. And we're looking at HGL. So let's see, HGL. HGL looks like it's the base of this prism. And so the intersection would be this line right here from, I guess that's going to be kind of hard to read that, but ML. So we could say line ML. All right, letter B, it says name a point coplanar. So we want to be on the same plane to points F, K, and J. So F, K, and J. Let me erase this. F, K, and J. That's going to be this plane up here. Here's F to K to J, so it's this piece right here. Point coplanar to this. How about E? E is on this plane. Letter C, are points E, J, and G coplanar? So let's see. We've got E is right here, J, and G. Can I draw one plane that will capture all three of these? No, because it looks like E and J are on this plane here, and then G is the corner here. So it could be on this plane here, or it could be on that bottom plane as well. So I'm going to say no, because G is on a different plane. All right, so distance formula. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Midpoint formula, we add the x's, divide by 2, and we add the y's, and we divide by 2. That'll give us the middle point of 2 points. Used for questions 3 and 4, given line segment AB with these endpoints. So what I'm going to do is just do a quick sketch. And let's see, I've got -1, 7 is like right here. And 11, -1 is like right here. So my line is somewhere over here, just to give me an idea of what I'm looking at. Find the length of AB. All right, so I'm going to go ahead and write my points again, -1, 7, and 11, -1. I'm going to call this guy my first x, my first y, second x, second y. And then the length can be found with the distance formula. So this is going to be x2 minus my x1 squared plus y2 minus my y1 squared. All right, so let's see, I have a double negative here, that's plus. So that's 12 squared is 144. And let's see, -1 minus 7 is -8 squared is 64. Grab a calculator. Square root of 144 plus 64 is square root of 208. And that is about 14.4. Find the midpoint of AB. All right, so I'm going to use my x1, y1, x2, y2, and just plug them into my midpoint formula. So I'm going to add the x's, divide by 2, and I'm going to add the y's, divide by 2. So the x will be -1 plus 11. That's going to give me 10 divided by 2 is 5. And 7 plus a -1 gives me 6 divided by 2, which is 3. And let's just make sure that looks about right. Does it look like we're going to have a midpoint about 5, 3? Yeah, about right there. Okay, number 5, a segment has a midpoint of 2, -7, and an endpoint of 8, -5. All right, so this one's a little different the way we're setting it up, because we know our middle x is going to be 2, and our middle y is -7. And let's just go ahead and call this my x1 and my y1. All right, so x1 plus x2, which is the missing guy, divided by 2 is equal to the middle x. Okay, so that's what we set up to find our other x. We're going to do something similar for the y's. So my y1 plus my y2 divided by 2 is equal to the middle y. All right, so I'm going to multiply both sides by 2 on both of these equations to get it to cancel in the denominator. All right, so over here, that cancels. I have 8 plus x2 is equal to 4. And if I subtract 8, x2 is going to be -4. All right, on the y equation, let's see, I'm going to have -5 plus y2 is equal to -14. Add 5, and so y2 is equal to -9. So my missing coordinate is going to be -4, -9. Number 6, if x is the midpoint of wy, wx is equal to 3x minus 1, and wy is equal to 10x minus 26. Find wy. Okay, so let's see. So we have w somewhere here, and y somewhere here, and x is the middle. If it's exactly in the middle, that means that both of these pieces are congruent. So wy, the whole thing, is equal to, let's start with wx is equal to, well, 3x minus 1. wy, the whole thing, is equal to 10x minus 26. Find xy. Okay, so let's see. I could double the wx measure and set that equal to the wy measure. Okay, because each of these pieces are the same length, so I have 2 of those pieces to equal the whole thing. All right, so let's distribute, combine our like terms. So 2 times 3x minus 1 will give you 6x minus 2, 10x minus 26. Let's take away 6x on both sides. Let's add 26 to both sides. So I end up with 24 on the left is equal to 4x. If I divide both sides by 4, x is equal to 6. I have not answered the question because the question says find xy. So, but that's congruent to this piece right here. So if I plug in a 6, 3 times 6 minus 1, 3 times 6 is 18 minus 1 is 17. That's how long each of those segments is. So xy is equal to 17. All right, number 7, find the value of x. Okay, so what we've got here are 2 vertical angles, and we know that vertical angles are congruent. So let's set these 2 equations equal, or 2 expressions equal. So I'm going to subtract 5x on both sides and add 18 to both sides. So this is going to give me 7x is equal to, well, let me add this together. 59 plus 18 is 77. So x is equal to 11. Now it wants me to find the measure of this angle WYX. So W to Y. Oh, it's asking me for this angle. All right, so I'm going to have to do a little bit more math because I don't know what this angle is. So let's first plug our x value into one of our given angles. So like this one on the bottom, 5 times 11 plus 59. That's going to give me 55 plus 59, which is 114. So that's the measure of this angle here. I want this angle over here. They are a linear pair. That means they are supplementary. Supplementary means they add to 180. So if I subtract 114 from 180, that gives me 66, which is the measure of that angle. All right, number 8. If the measure of L in K, L to N to K, I'm going to highlight so I know what I'm looking at. L to N to K, that's this angle right here. And the measure of K in M, so K to N to M is equal to 10x minus 3. Find the measure of J in M. So what it's asking me is for J in M, this guy down here. All right, so first thing, I need to start with what I'm given. I'm given two angles that are supplementary. They are a linear pair. That means they add to 180. So let's add these up and equal to 180 so that I can solve for x. So let's see, I have 15 x's and minus 30 if I combine my like terms. If I add 30 to both sides, I'll have 15x is equal to, well, I believe that's 210. 210 divided by 15 is 14. Okay, so it's asking me about J in M. That's what I'm looking for. Well, that angle is congruent to L in K. So if I can figure out what L in K is, then I will know what J in M is. So let's take that 14 that we found and plug it in to the expression for the L in K. So 5 times 14 minus 27, and that gives me 43. Number 9, find each missing measure. Okay, so I'm given a bunch of stuff. Let's see, well, I want to find the measure of DBC. So D to B to C, that's this guy here. All right, so first thing, let's see. Let's start with this 148 that we're given. That's this angle here. Well, these two angles are a linear pair. They're supplementary. So if I subtract 148 from 180, that'll give me 32. So I know that this angle is 32. So that's x. Well, x is going to be vertical from z. So that means z is also 32. All right, let's see, I know this guy is 90 because that's a right angle. And let me go ahead and write in 32 for the z. And well then, I know that these two angles are complementary. That means they add to 90. And so y is 58. All right, so now let's answer these questions. So the measure of angle DBC. So D to B to C will be 32 plus 90. So 32 plus 90 is 122. And that was 32 plus 90. And the measure of ABE, so let's take a look. A to B to E, so it's going to be this, whoa. It's going to be this big angle, A to B to E. Let's see, or is it? I'm not sure. Is it asking us about this angle, ABE, this obtuse angle? Or is it asking me about ABE, this angle? So just to make sure, I'm going to figure out both, and then we'll check the answers later. All right, because when you're talking about an angle, A to B, this could be my vertex angle to E. I could have this greater than 180-degree angle, or A to B to E, I could have this angle, which is also obtuse, but less obtuse than that first one. So let's just figure out what both is. If I'm going to do this big angle, I would add 32 plus 148 plus 32, which would be 212 degrees. But if it's asking me for this angle, that would be the sum of, well, 58 plus 90. And that would be 148. So on your test, it will be very clear which angle you're solving for. All right, number 10, if QS bisects, if you're bisecting, you're cutting into two equal parts. QS is cutting these angles, so I know that these angles are congruent. So I've got 4x minus 25 is equal to 2x plus 7. I'm going to do this first to find my x. So subtract 2x both sides and add 25 to both sides. This gives me 2x is equal to 32 and x is equal to 16. Question's asking me for PQR. P to Q to R, the whole thing. Okay, so let's just plug in 16 for both of these. So 4 times 16 minus 25 and 2 times 16 plus 7. And then I can add those together. This gives me 39. And this also gives me 39. And that's a good way to check because I should have gotten the same value. If I add those together, I know that the big angle is 78 degrees. Number 11, angles R and S are complementary. Complementary means 90. They add to 90. So measure of angle R is 6x minus 47. S is x plus 4. We know these add to 90. So let's just go ahead and add these together. So that's going to give me 7x minus 47 plus 4 is going to give me minus 43. I'm going to add 43 to both sides. So 90 plus 43 is 133. If I divide both sides by 7, that gives me x is 19. That doesn't answer the question though. It asks me for the measure of angle S. Measure of angle S is x plus 4. So I'll plug in the 19, add 4, and I get 23 degrees. Number 12, angle C and D are supplementary, mean they add to 180. If the measure of angle D is 9 less than twice the measure of angle C, so 2C minus 9 equals D. Angle C and D, so C plus D equal 180, right? That's what supplementary mean. Measure of angle D is equal to 9 less, that means we're subtracting 9, twice the measure of angle C. So here's the 2C minus 9. Okay, so that means our D value over here in this equation, replace the D with 2C minus 9. And we do that so that we only have one variable. If you have more than one variable, you cannot solve the equation. All right, so this is going to make 3C minus 9 is equal to 180. Add 9, so 3C is 189. 189 divided by 3 is equal to 63. So C is equal to 63. I don't know what D is, though, and that's my question. Find the measure of angle D. Well, I do know that C plus D equal 180, and if C is equal to 63, I can figure out what D is by subtracting 63. And so D is equal to, well, 180 minus 63, 117. Give a counterexample for the following statement. All composite numbers are even. Okay, so let's talk about a counterexample is an example that's going to disprove a statement. So let's think about composite numbers now. Composite numbers have factors more than just one in itself. So let me give you an example. 4 is a composite number. Its factors are 1, 2, and 4, because 1 times 4 is 4 and 2 times 2 are 4. Well, but this is an even number. That doesn't disprove. So I'm going to need to come up with something else. How about 9? What are the factors of 9? Well, 1 divides evenly 9 times, and also 3. 3 times 3 is 9. And so 9 is an odd number. So a counterexample is finding an odd number that's composite. Give a counterexample for the following statement. If a figure has 4 sides, it is a rectangle. Well, we know that there are lots of other figures that have 4 sides that are not rectangles. How about a rhombus, or a diamond, or a trapezoid? That is definitely not a square. A counterexample is at least one example that disproves a statement. Use the following statements to write conditional statements, determine the truth value. So here's the P and here's the Q. Our conditional statement is if P, then Q. Remember, it's the if-then. So if 2 angles are adjacent, then they form a linear pair. I'm going to say that this is false because I can have 2 acute angles that are adjacent meaning next to each other, and a linear pair means they add to 180. So my little diagram over here with my 2 acute angles definitely do not add to 180. Okay, so the inverse, that is the negation. If not P, then not Q. So if 2 angles are not adjacent, then they are not a linear pair. Oops, sorry about that. Aw. All right. It messed me up. Okay, so if 2 angles not adjacent, converse, switch. If 2 angles form a linear pair, then they are adjacent. Contrapositive, switch, and negate. So if 2 angles do not form a linear pair, then they are not adjacent. All right, let's keep going. Biconditional. This is the if and only if. So 2 angles are adjacent if and only if they form a linear pair. I guess we're supposed to write a biconditional for those statements. Not 100% on that one. All right. But anyway, biconditional is the if and only if. Number 18, use a diagram to the right to answer the questions below. Okay, name a plane parallel to plane DEFGH. Goodness, DEFGH. Okay, well that's this base guy on my prism, and parallel, well, would be this base on the other side. So that would be, name a plane parallel. Well, let's call this plane, and planes are named with 3 letters. So how about NML? That's one way we can name it. Any combination of 3 letters on the back plane would be fine. Name 2 segments parallel to GL. Okay, so let's see. GL is going to be this guy right here. If I want to be parallel, how about FK and EJ? Parallel means they are not going to ever intersect. These guys will never intersect. Name a segment parallel to NM. Okay, let me erase this. So NM is this guy. If I want to be parallel, how about DH? Use a diagram to the right to classify each pair of angles. Angle 1 and angle 8. These are alternate exterior. AEA, alternate exterior angles. They are on the opposite side of this transversal. That's what makes them alternate. And the interior of the lines is right here between the 2 lines. So we can see that they are alternate and on the exterior. Angle 6 and angle 7. Okay, so 6 and 7, those would be same side interior. 2 and 4. 2 and 4, this guy on the interior, this guy on the exterior, they are actually in the same position. 2 and 4, they are corresponding.
Attention faculty, students, all. If you have a
angle 3 and angle 6, these are alternate interior.
Please move all vehicles from the banned parking lot in
3
the
and 6.
immediately.
All right, number 20, on a number line, point A is located at -5. Okay, so this is different. Here's my number line. Point A is at -5. And point B is located at 15. Determine the location of a point 3/4 the distance from A to B. Okay, well, we've got to figure out what is the distance from A to B. Well, that would be -5 minus 15, and it's a distance, so it's the absolute value of it. And so this would be the absolute value of -20, or 20 units. So that's the whole distance, 20 units. If I wanted 3/4 from A, that means I'm moving this direction. Well, 20 times 3/4, let's see, I can reduce the 4 and the 20. 1 and 5. 5 times 3 is 15. I want to be 15 units from A. So I'm going to be moving 15 units this direction. Well, -5 add 15 will give me 10. So this is the point that is 3/4 the distance from A to B. All right, number 20. My goodness, this review goes forever. Measure of angle 1, if L and M are parallel. Okay, so that's important when we're looking at angles. L and M are parallel. And let's see, we've got one angle on there, it's 52. Well, I'm going to go ahead and fill in as much as I can. This 52 is vertical from angle 3. So I don't know why I wrote 53. How about 52? And then 3 corresponds to angle 7, so that's also 52. And that would be vertical with angle 9, which would be 52 also. All right, let's see what else we know. Okay, so, well, I could figure out what 6 is because these would be a linear pair. So 180 minus 52 would give me 128. So angle 6 is 128, and that's vertical from 8, so this is also 128. All right, let's see what else I can figure out. Let's work on, change my color. I know that this angle is 87, so this is a linear pair here, and 87 is also vertical from 11. So let me go ahead and call this 87, and then subtract from 180, and I'll get 93. Vertical from angle 12, so this is also 93. Now I can figure out what angle 4 is, because this guy in the middle is just a big triangle, a little triangle. So if I added 93 plus 52, that's 145. If I subtract that from 180, that gives me 35. So angle 4 is 35. 4 is vertical from angle 2, so that is also 35. All right, so now I see that I've got, well, these two, I can add those together. So 35 plus 52 is 87, because then I've got a linear pair here, and I can subtract 87 from 180 to get this angle here at 93. And angle 1 is vertical from angle 5, and so this guy is also 93. And I think that answers all the questions on that table. All right, 21. If Q is parallel to R, so let's just, Q and R are parallel. Solve for X and Y. All right, so here is my transversal. And this guy and this guy both have X's in them, and I can see that they are alternate exterior angles, which are congruent. So I will set them equal and solve for X. So 7x minus 10 is equal to 9x minus 44. Let's take away 7x on both sides and add 44 to both sides. This gives me 34 on the left is equal to 2x, and if I divide, I get x is equal to 17. All right, so I'm going to plug in my 17 here. So 9 times 17 minus 44, this angle is 109. It is going to be supplementary with the 30y minus 19. That means they're going to add to 180 because they're on a straight line here. Okay, let's solve for the y. All right, well, on the left, I've got 109 minus 19. So 109 minus 19. On the left, I have 90. If I go ahead and add that to the right, I'll have 30y is equal to, well, 90 plus 180 is 270. If I divide both sides by 30, or just 3 if I cancel a 0, I'm going to have y is equal to 9. So my y value is equal to 9, and my x value is equal to 17. 22, if M is parallel to N, so M and N, my transversal is right here, and these two angles, these are same side interior. Same side interior are supplementary. That means they add to 180. Okay, so on the left, I've got 8 x's and I've got 21 x's. That gives me 29 x's. 1 and 5 add to 6. Take away 6. And if I divide both sides, 174 divided by 29, x is equal to 6. 23, use the diagram to answer the questions below. The measure of angle 1 is 84. What must be the measure of angle 5? Well, if they're parallel, that means those would be corresponding, and corresponding are congruent. If the measure of angle 2 is 109, okay, so these are obviously different problems, so I'll erase. Measure of angle 2 is 109. What must be the measure of angle 9 be? All right, so in this one, I would be looking at these two lines, A and C. Those would be on the same side interior, so those would be supplementary. So then I would need to find the supplement of 109. So I would subtract 109 from 180 and get 71. Measure of angle 5 is 68. So let me erase and focus on my next problem. So measure of angle 5 is 68, this guy. What must be the measure of angle 11 to prove B and C? B and C. Okay, and so here's the transversal. These would be alternate exterior, which would be congruent. So this guy would be 68. Measure of angle 3 equals the measure of angle 9. So let's see, measure of angle 3 is equal to the measure of angle 9. What converse proves A is parallel to C? The converse of the alternate interior angles. Measure of angle 8 is equal to measure of angle 12. So 8 and 12. What proves B parallel to C? That would be the converse of corresponding angles. Measure of angle 2 plus the measure of angle 5 equal 180. So let's look at that. 2 and 5 add to 180. What proves A is parallel to B? Well, that would be the converse of the same side interior angles. Okay, which angle pairs are congruent? Okay, and so it does show us that these guys are parallel. This line parallel to this line. So which angle pairs are congruent? Well, angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. These would be corresponding angles. 2 and 6 and 1 and 5 are both corresponding angles. Now on the other side of the transversal, we could look at angle 4 corresponds to angle 7. Also, angle 3 corresponds to angle 8.
Attention students, Sydney Childress and Kendall Vernon, please move your vehicles
All right, we also
from the
have
band parking lot. Sydney Childress, Kendall Vernon,
alternate exterior.
please move your vehicles from the band parking lot immediately.
Angles 1 and 8, also angles 4 and 6. Those are all alternate exterior. Angles 3 and 5. Those would be alternate interior, and angle 2 and 7, also alternate interior. So there's lots. Okay, which angle pairs are supplementary? Supplementary mean they add to 180. And we know supplementary starts with an S, same side starts with an S. So angle 1 and angle 6 are supplementary. Those would be same side exterior angles. Angle 4 and angle 8. Angle 2 and angle 5, those would be same side interior. And angles 3 and angle 7, also same side interior.